This is Professor Derek Seitz, Statistics Data Classification. At a very high level, there are two kinds of data, qualitative data and quantitative data. Qualitative data is essentially non-numeric, and it's not involved in meaningful arithmetic. Quantitative data, on the other hand, is numeric, and it is involved in meaningful arithmetic. Examples of qualitative data include color, like red, green, blue, an ID number. Although it's numeric, it really its only purpose is to provide a unique label for something, such as a student ID or a social security number. It's not really intended to be involved in any arithmetic, not meaningful arithmetic. Name, gender, male, female, city, or rank. Most popular, second most popular. Examples of quantitative data, which are all numbers: age, height, weight, date and time, grade point average, numeric in a 4-point scale, and income, a monetary data item. Within those higher categories of qualitative and quantitative data, there are 4 levels of data. And what distinguishes them is the kinds of operations you can do with them. And this table summarizes this information. These columns here, you can see the different operations. So the first column is whether or not you can count certain values, such as the number of males, number of females, the number with a given birthday. All the different kinds of levels of data can be counted. The next operation of interest is to be able to order the data. Nominal data cannot be ordered. Ordering starts with ordinal data, and the levels higher than it can also be ordered. So these 3 levels have a natural ordering, whereas this nominal levels does not have any natural ordering. The next is to be able to look at differences between data values. But in this column here, where we're dealing with data that has no true zero, concept of a true zero, where that means total absence of something. So the interval and the ratio levels can look at differences, whereas the ordinal and the nominal differences do not have any meaning. And the last column is where you look at the ratio of 2 values. Only the ratio level data. You can do that because that data has a true zero, where there's total absence of something. Some examples of these levels: nominal, color, name, gender, city. Ordinal, where we can order things. ID numbers can be ordered. Letter grades, ranks. Interval, where we can look at differences but not ratios, because there's no absolute zero. Dates, in our system of dates, do not have an absolute zero. They go back to a certain point, and then they go before that point. They keep going. They don't have like where time began here. Our system doesn't have that. Temperatures in the Celsius and Fahrenheit scale also have arbitrary points that they call zero. And if you go below them, there's still some movement. There's still, if you want to call it heat, it's cold, but it's still temperature. It's not an absolute zero scale. Ratio, all these things here, ages, zero, they have all true zeros. Height, weight, grade point average, income, time of day, a little bit tricky if you're doing 12-hour clock, but you can still look at differences if you use an algorithm that takes into consideration the AM, PM. Of course, the 24-hour clock is much easier to look at differences. And also ratios you can do because there is a zero. The day starts at a certain point at midnight, and that's a true zero. A time span, also known as a duration, is also ratio data. And a temperature scale called Kelvin has an absolute zero on the scale where there's no movement at all and nothing below that. So in statistics, it's useful to be able to understand the differences in these kinds of data.